Uh, so good morning. This is the second problem that we are going to discuss. A rigid prismatic weightless bar AB is supported in a vertical plane by a hinge at the end A and by a horizontal string attached at the bar B as shown. The end B of the bar carries a load W. Find the tension in the string and the direction at the hinge in terms of W and theta. So this is the question. So you have a bar AB, a rod AB, which is supported by a hinge at A, and a weight W is hanging from the other end. To prevent it from falling down, you have attached a string at the midpoint of the rod, and that string is attached to that vertical. So you're asked to find the tension in the string and the direction of reaction at the hinge A. So this is a typical problem. So as usual, the first thing that you need to do is to draw the free body diagram of the rod A. Okay. So to analyze what all are the forces acting on this rod A. So if you consider the action is the weight W. The weight W is the one which makes it move down. Like so, W is acting vertically downward. Okay, so let's first mark that. So you have a weight W acting here vertically downward. Like you have the weight W. Since this angle is theta here, so this angle here will be theta. Right? So this angle here will definitely be theta. Since this angle is theta. So this is the action. Now look at the reactions. The tension in the string, right? So this string here is pulling the rod to the left. So it is attached to the midpoint of the rod. So if you just look at the midpoint of the rod here, somewhere here, so there is a force acting to the left. So that is the tension. So you have your say somewhere here. So you have the tension acting to the left. This is the second force. Now the third force is the reaction at the hinge. The hinge support will offer resistance or restriction in the both x and y directions. Right? So you have a reaction in the x direction. I'll just put it. ഒരു reaction ഉണ്ടാവും, which is XA. And then you will have a reaction in the vertical direction, which is YA. So XA and YA and reaction ഉണ്ടാവും. അപ്പോൾ അതിൻ്റെ ഒരു റിസൾട്ടന്റ് ഫോഴ്സ് ഉണ്ടാവും അല്ലേ? റിസൾട്ടന്റ് ഈസ് RA. ഞാൻ ഇതിനൊരു പാരലോഗ്രാം പോലെ കൺസ്ട്രക്ട് ചെയ്യുകയാണെങ്കിൽ you will have a reaction, resultant force acting here. Okay, so this resultant is RA. So you have a resultant here, RA. And this resultant is making an angle alpha with the horizontal. So when you draw the free body diagram, you are going to mark the resultant reaction at A. അതാണ് നമ്മുടെ ക്വസ്റ്റ്യനിൽ ചോദിച്ചിട്ടുള്ളത്. So if I mark here, so you have a reaction acting at A, straight line വരയ്ക്കാം. So you have your reaction acting into it. ഇവിടുന്ന് say ഇങ്ങനെ. Right? So that will be your reaction. A reaction RA, which makes an angle of, say, alpha with the horizontal. So you have a case where there are three forces acting on a rod AB and it is in equilibrium as a result of it. There can be equilibrium, or this rod AB can remain in equilibrium only if these three forces are concurrent. അതാണ് ഇതിനകത്തുള്ള ഈ പ്രോബ്ലത്തിലെ ഒരു മെയിൻ പോയിന്റ്. Equilibrium can exist only if these three forces are concurrent. Right? അപ്പോൾ ഇത് concurrent ആവണമെങ്കിൽ which is a point at which all these forces meet. So if you let this tension T, right? So we tension T consider that if I just extend this line, right, it will meet the line of action of W here, right? അപ്പോൾ ഇവിടെ അത് ആക്ട് ചെയ്യും. Say suppose that point is C. Suppose this particular point is C here. The body is in equilibrium means the reaction RA should also pass through this point C. Clear? എന്നാലേ അതിന് equilibrium ആവാൻ പറ്റുള്ളൂ. So if you extend, if you draw the line of action of the resultant, it should also pass through this point C. എങ്കിൽ മാത്രമേ ഈ മൂന്ന് ഫോഴ്സസ് ഇക്വിലിബ്രിയത്തിലാവാൻ പറ്റുള്ളൂ. സോ ദാറ്റ് ഈസ് ദ മെയിൻ പോയിന്റ്. അപ്പൊ ഇതിങ്ങനെ എക്സ്റ്റെൻഡ് ചെയ്താൽ it should also pass through the point C. Clear? Now you have three forces in equilibrium. So you have T, W, and RA. Now you can straight away write equations of equilibrium and then find value for T and RA. So as usual, I'll just represent these forces alone in an XY plane. So if I draw a y-axis and then an x-axis. So this is your x direction. This is x direction, and here you have y, positive y. You have the three forces acting. I'll just mark one by one. You have the force W, which is acting downward. You have the force W. T acting to the left, horizontally to the left. You have the tension T, and you have the RA. You have RA, right, making an angle alpha with the horizontal. So this is RA, and this is making an angle alpha with the horizontal. Now these are the three forces acting. You can write equations of equilibrium. Say sigma Fx equal to 0. Right? To write this equation, you need to resolve RA. Right? RA in x and y direction. So you put draw horizontal down. So you have the component of RA in x direction. I'll write it as, say, RA x, which is nothing but RA cos alpha. You can also have a component of Ra in the y direction, right? You solve along y direction. So you will get Ry. So Ry, so Ray, which is nothing but Ra sin alpha. So you have two components, Ra cos alpha and Ra sin alpha. This is with in mind, we can write equations of equilibrium. So sigma fx equal to 0 means the force in the x direction is Rax or Ra cos alpha minus t is equal to 0. It's equation number 1. Write sigma fy equal to 0. Okay. Sigma fy equal to 0 means in positive y direction you have Ra sin alpha minus w, so that is equal to 0. You have equation number 2. Okay. Now you have to solve these two equations and then find value for t. Now from equation 2 you find that Ra is w by sin alpha. Right? You substitute this Ra in equation in equation 1. So this is Ra in 1. You find that t equal to Ra cos alpha, but Ra is w by sin alpha, so w by sin alpha into cos alpha, so you get t as w cot alpha. So this is the value for t. This is how you find t, but the problem here is we don't know this value of alpha. So in the question you are asked to find this value of alpha. നമുക്ക് ആൽഫ എന്താണെന്ന് കണ്ടുപിടിക്കണം. Okay, so you have to express alpha in terms of theta. So that is our next task. So for that, if you again consider this figure, so this is the case. We know that t equal to w cot alpha. Now we are trying to find or represent alpha in terms of theta. You have to express alpha as a function of theta. So just a geometry involved. What you do is, say if you extend this straight line here, so if you extend this straight line here, it will meet at this point. Suppose this point is say M. Okay, you consider a triangle. So we have a triangle, a right triangle, AMB, a right triangle AMB. Okay. Now you take say cosine of that angle theta. So this angle is theta here. So how much is cos theta? Say cos theta is adjacent side by hypotenuse length. So BM by AB. Okay. So we'll find BM as AB cos theta. How much is AB? AB is the length of the rod. So AB is L. So L cos theta. So you got BM. Now if you look at this angle CM, at CM will be exactly half of that, right? So CM is actually BM by 2. So it will be say L by 2 cos theta. So this is let's put it as 3, equation 3, something like that. Now again, if you take sine of this angle, say sine theta. Sine theta is opposite side by hypotenuse, so AM by AB. So we get AM from this equation. So we get AM as this length AM as AB sine theta. So AB is L. So we get this at L sine theta. Sorry, it is theta. So this is sine theta. So you found an expressions for CM and AM. Now we can go consider another small triangle, this ACM or AMC, another small right triangle, say AMC, another triangle here. From this, our interest is cot alpha. No? You look for a substitution for alpha. So how much will be cot alpha? Cot alpha is adjacent side by opposite side. Like adjacent side is AM. Opposite side is CM. So we know both these. AM is L sine theta. CM is L by 2 cos theta. So if we deduct this, we get cot alpha as this L gets cancelled and we get it as 2 tan theta. Right? Or our question is this direction. Direction is our exam. The question question or value direction of the reaction. Right? So we can get alpha. So alpha is cot inverse 2 tan theta. So this is alpha. Now again, you can also express t in terms of this t in terms of theta. So t is in fact w cot alpha, but alpha is 2 tan theta. So get it as w into 2 tan theta, or t equal to 2w tan theta. So these are the two answers. The first question was the tension in the string, that is 2w tan theta. And what is the direction of the reaction? That is alpha. Alpha is cot inverse 2 tan theta. Okay, so this is a very interesting problem, and it's used to come for exam. Okay, thank you. So I'll just stop it here for the day.